Hello. Today we are learning about a third form of a linear equation. This form is called point slope. It's called point slope because you know the slope and a point right from the equation. So our point slope form is y minus y1 equals m times x minus x1. M, just like it has been in every form when we've seen it, m is our slope. x1 and y1 come from any point on the line. Now notice, if you're looking at the equation, that we are subtracting we are subtracting the y from the point from the variable y in our function. We are subtracting x1, the x value from the point, from the x value in our function. So let's look at an example, and this is example 1 in your notes. Okay, example 1. So we want to figure out what is the equation that goes through the point 2, -4, and has a slope that equals 3. Okay, so in our point slope form, we know that we are going to replace the m with 3, because m, our slope, is 3, and we're going to replace x1 with 2, because our x value in that point is 2, and we will replace y1 with -4, because our y value in our point is -4. So as we write it, we see y minus -4 equals 3 times x minus 2. Now, we don't like having minus and negative, and so we change that. When we subtract a negative, we know that's the same thing as adding, so I can write y plus 4 equals 3 times x minus 2. And this is the point slope form of the equation for the line that goes through 2, -4 and has a slope of 3. Example 2 is very similar, okay, but going the other way. So here again is our point slope formula. In example 2, I want you to use this equation, y minus 1 equals 1/3 times x plus 3, to identify the slope and a point right from this equation. Well, our m, notice 1/3 is where m goes, 3 is over there where x1 goes, and y1 is where that 1 is. Okay, so we know right away our slope is 1/3, because again, 1/3 is replacing the m. Our point is going to be, the x value of our point is what we're subtracting from x, and the y value of our point is what we're subtracting from y. So this goes through the point -3, 1. Again, I am subtracting -3 from x. X minus -3 gives me that x plus 3. And I'm subtracting 1 from y. Y minus 1. Okay? It's almost as if when I pull out my x and y value from the equation, I have to flip the sign, change the sign. So we have now talked about 3 forms of an equation. We've talked about slope-intercept form, and slope-intercept form is y equals mx plus b. We know in that, just like always, m is our slope. B, although we don't really know why, b stands for the y-intercept, so it's where the graph will cross the y-axis. So it's called slope-intercept, slope and y-intercept. We've also talked about standard form. Standard form is capital AX plus capital BY equals capital C. And we know in standard form we've got those 3 things that must be true. We need X and Y to both be on the left. We need the numbers where A, B, and C go. They're capital letters to remind us that we can't let those numbers be fractions. And then we also need to make sure that A is a positive number. And the third form that we have is point slope form. So y minus y1 equals m times x minus x1, the new form that we just have talked about today. Now, these three forms, for different reasons, we will need to use the different forms. We like point-slope form because it's very quick for us to write an equation for a line that has a certain slope and that goes through a certain point. That's why it's called point-slope. We like slope-intercept and standard form. They're easy for us to graph like we've done in the past. And standard form is going to be useful to us later when we're solving systems of equations using what we call elimination. Slope-intercept form will be useful to us later when we're solving systems of equations using what we call substitution. And so these forms are going to keep coming up. And we need to be able to shift back and forth. And so like we did last class, example 3 is asking us to write the equation of the line that goes through 2 points. And so example 3 at the bottom of the first page in your notes, I want you to make sure that you have in your notes that we're going through the point 4,6 and the point 7,3. Okay. Now we're going to not just write the equation, but we're going to write the equation in point-slope form, in slope-intercept form, and then in standard form. But to do any of that, I need to find the slope first. So our slope, to find our slope, we have to use the slope formula. Remember that is m equals y2 minus y1 divided by x2 minus x1. The x and the y are the numbers in our points, okay? And the 1s all come from the same point. The 2s all come from the same point. So when I have plugged in my y2 minus y1, we have 3 minus 6. And my x2 minus x1 on the bottom, I have 7 minus 4. So notice we have done our rise, the difference in the y values, divided by our run, the difference in the x values. When I simplify, 3 minus 6 is negative 3, 7 minus 4 is positive 3, and negative 3 divided by positive 3 is negative 1. So my slope that goes through these 2 points is negative 1. I want to use that slope and one of my points in order to write my slope, my point-slope form. So here's our point-slope form. I'm going to choose that x1, y1 point, and I'm going to choose my slope and plug those 3 things in. So our point-slope form is y minus 6, that was our y1, equals negative 1, our slope, times x minus 4, that was our x1. So hopefully you see I've color-coded it there so you can see where the numbers came from. That's our point-slope form. The next form that is on your worksheet, we want to have the slope-intercept form. And our slope-intercept form, we need y to be by itself, and we need there to be no parentheses. So the first thing I should do is distribute along my parentheses. So I want to multiply negative 1 times x and negative 4. So we've done that, and we have y minus 6 equals negative x plus 4. Now, I just need to get y by itself. So we'll add 6 to both sides, and I have the equation y equals negative x plus 10. The next form we need to have is our standard form on your notes. And standard form requires that we have x and y both on the left, and that we have no fractions, and that the coefficient, the number in front of x, is positive. So as I first move x to the left, I have to add x to both sides, and we get x plus y equals 10. Notice here there are no fractions. Notice the x is positive, and so it is in standard form. So we have our point-slope form, our slope-intercept form, and this box is supposed to be over the standard form, which is x plus y equals 10. Example 4, the first example on the back of your notes, asks us to write the equation of the line that goes through these 2 points. So we want to go through negative 5, 6, and negative 1, 4. Just like in example 3, the first thing I need to do is find the slope. We're going to find the slope by using our slope formula. We wrote it out in example 3, but here I just want to plug it in. So as we look at our points, we know we're going to have m equals 4 minus 6 divided by negative 1 minus negative 5, so that's negative 1 plus 5. As we keep going, we get negative 2 divided by positive 4, so we see that our slope is negative 1/2. I want to use that slope and one of our points to plug in point-slope form. So point-slope form, we have y minus 6 equals negative 1 over 2 times x plus 5. Now, x plus 5 is again there because our x that I plugged in is a negative number. So it's x minus negative 5, x minus negative 5, which becomes x plus 5. This is our point-slope form in red. To get to slope-intercept, just like we did in example 3, I need to distribute my slope across the parentheses, and once I've distributed it across the parentheses, so I get y minus 6 equals negative 1/2 x minus 2.5, then I need to get y by itself by adding 6 to both sides. Our slope-intercept form then is y equals negative 1/2 x plus 3.5. Standard form is a little more complicated. We want to get x and y to the same side, get rid of all fractions, and make sure that our x is a positive number, that our x coefficient is a positive number. So as I get x to the left, I need to add 1/2 x to both sides. So I end up with 1/2 x plus y equals 3.5. I want to kill the fraction, so I'm multiplying every term by 2, and so we get x plus 2y equals 7. And in orange, that is now our standard form of this equation. So we have found the 3 forms of our equation: point-slope, slope-intercept, and standard form. Example 5 asks us to write 6x minus 2y equals 18 in slope-intercept form. Well, we're going to start with that equation, 6x minus 2y equals 18. And again, to get to slope-intercept form, I need to get y by itself. So the first step is to move the x over. X is positive, so I'm subtracting 6x from both sides, and I get negative 2y equals negative x plus 18. Now, I am multiplying y by negative 2, so to undo that, we're going to divide every term by negative 2, and we see our slope-intercept form of this equation is y equals 3x minus 9. That's our slope-intercept form. Example 6, we want to write y minus 2 equals 2 times x plus 4 in standard form. Now, standard form, we need x and y to both be on the left, there to be no fractions, and the number in front of x has to be positive. Those 3 things, every time, make it in standard form. So as I'm looking at this, the first thing that has to happen is I have to get rid of those parentheses, because there's no parentheses in standard form. So we're going to distribute 2 times x and 2 times 4. Next, I need to get x over to the left, and that number minus 2 that doesn't have the x or the y, I need to get it over to the right. So let's move the number first. I'm going to add 2 to both sides, so y equals 2x plus 10. And then I need to move the x over, so I'm subtracting 2x from both sides, so negative 2x plus y equals 10. Now notice the x is negative. I can't let it be negative. So I'm going to multiply every term times negative 1. So we have 2x minus y equals negative 10. This is that same equation in standard form. Our last three examples here, or this is example 7, these three graphs, we're going to graph three equations. The first equation, equation 1 here, is in point-slope form. This is called point-slope form because from it, I can see that my slope is 2, and the point, our x value is being subtracted from x, our y value is being subtracted from y, and so the point is 1, 3. To graph this, I can go straight to that point, 1, 3, and graph that spot. Then I want to move according to our slope. Slope, again, has the meaning rise over run. Unless it's in a fraction, it's hard to figure out what my rise is and what my run is. So our slope being 2, not in a fraction, the first thing I want to do is make it a fraction. So we're going to put 2 over 1. Now I can see my rise is a positive 2, so I'm going up 2. My run is a positive 1, so I'm going right 1. So from that point, I'm going up 2, right 1, up 2, right 1. We can make as many dots as possible. Once I feel like there are enough dots, then we can draw our line through all of them. This is how to graph a point-slope equation. Find the point, make a bunch of other points based on the slope, and draw your line. Equation 2 asks us to graph the equation 2x minus 5y equals 10. This is an equation in standard form. This is equation 2 on your notes. And to graph this, we have to find our intercepts. To find the x-intercept, we make y 0. And if I make y 0, negative 5 times 0 is going to go away, and all I'm left with is 2x equals 10. So when y is 0, if I solve for x, I get x equals 5. That's my x-intercept, right there at 5. I want to do the same thing for y. So I'm going to put 0 in for x, and I'm left with negative 5y equals 10. Then when I solve for y, I have to divide by negative 5, and I get y equals a negative 2. So my y-intercept is negative 2. These 2 points, when connected, make my line. This is how we graph an equation that is in standard form. Find our intercepts. In our last example, we've got an equation here that is in slope-intercept form. This is called slope-intercept because from it I can see right away that my b value, my y-intercept, is a positive 4. So this line is going to cross the y-axis at positive 4. I can also see from it, slope-intercept, I can see from it that the slope is negative 3 over 4. So from our y-intercept that is 4, we're going to go a rise of negative 3, so down 3, and a run of positive 4, so right 4. I can make as many points as I feel are necessary, and then connect them with a line. And this is how we graph a line that is in slope-intercept form.